let's get into JavaScript. So we've talked about, um, one second here. We've talked about HTML being the skeleton, right? And then CSS being the, I guess, the body, the flesh, the stuff that builds out a body, and then JavaScript being the brain, right? In our other example, when I showed you the stopwatch Google application, remember that we pointed out all of the different visual components. That's the HTML. And then we talked a little bit about the styling, the fact that some buttons were blue, the font was a certain size on particular parts. There was also some bordering on the different elements. And then in the center, you had you had this running time that was getting bigger and bigger and bigger as the stopwatch ran along. And you also could control that with the buttons, with start and reset. So what JavaScript does, enables us to do, is enables us to update HTML elements and control HTML elements and fire what's called events, right? A click. A click is like an event. You click it, and then it tells everybody in the web page, hey, somebody just clicked this button, and you can trigger things off of that. You can pick up that signal or that alert, right? And then you can cue things off of that. And so we're going to talk about JavaScript tonight. And for the first time, we're gonna really talk about what programming is, how to think programmatically. And I talked about this a little bit in our first lecture, but to me, like, the most simple way to think about it's like programming is writing to tell a robot what to do. So taking into account like very specific rules, taking into account like conditions, you know, like if you do this and something else happens because of that, do this, this, and this, and this instead. It also takes into account sequences of instructions, right? Like if I am going to tell my robot to do the same thing every morning at 8 a.m., the way that I would write that out would be different than if I was going to tell my robot to do something different every single day. So this is the way that we start to think about programming and programmatic thinking. So what is programming? It's concerned with transforming input into output. It's thinking about, I have a certain set of things, or I have a certain condition or certain state, and then the output, what can I do to change that or to transform it into something, and do something, build something with that. It involves logical analysis and decision making. So it involves thinking about things logically, maybe in a set of sequences, or maybe how things will affect different parts of the application, analyzing that, trying to figure it out, and then making decisions based on what you find. It involves completing tasks at scale. So it involves thinking about the way that we write the code, and maybe how another developer is going to read it, or how we can use a chunk of code and reuse it over and over and over again instead of having to write it out every single time. It's a social activity. The best way to code is to code with somebody else, so that you can talk about what you're seeing, so you can talk about the problem that you're trying to solve, and to get a completely different set of observations or opinions from somebody else to challenge you, and also to inform you of what you might be missing. And it's a creative process. It involves you taking all of these things, the logical analysis and decision making, thinking about how you're going to structure something, taking in the input from a partner, and creating new things, figuring out a way to create something new from all of these different inputs. The process, the general process for a developer is to write code, to code something out, to test it, and then figure out, okay, what is not functioning properly here, and what needs some improving. What's the sticky part of the application, right? And that's what we call debugging, figuring out what is maybe not optimal, or what's broken, or what's not performing as well as it can. And we take that information and we code again, and then we test again, we debug, and it's this loop until you complete a task of coding, testing, and debugging. So when we first approach a problem, the best way to start to think about what you need to do is by doing this thing called pseudocode, which is to break down the problem and to write out all of the steps that you intend to do without actually writing code, with maybe just writing comments or just speaking on it in however you're comfortable, whether that's like simple English, or some people like to write little scraps of programming languages. I like to just write things out in English, but it's a way to break down the problem into steps that are easy to understand without like going in and trying to implement it. So if we're creating a program, right, before learning the syntax and the concepts of a programming language, it's important to figure out like what the purpose of the program is. What should the program do? How should the program be structured? So we've got a couple examples here. First program that we get, somebody comes up and they say, hey, I need a program that texts me before I leave for work if there's a chance of a rainy day. Okay, so what we say is like, okay, we've kind of got like a when, where, why, right? We need something that looks to see if there is a rainy day. If it's going to be a rainy day, then it will fire off a text to a specific person, and it does that at a specific time, right before I leave for work. The second one here, I'm not in close touch with my family. I want to create a program that sends an automated email to each member of my family every Wednesday at 8 p.m. asking how their week was. Okay, so for pseudocode for this, I would probably sit down and I'd be like, okay, cool. When do we have to do this? We have to do this every Wednesday at 8 p.m. Okay, so I'm going to set up something that knows when it's 8 p.m. every Wednesday and will fire off some kind of instruction to kick off the program. What does it do? It sends an email. Who does it send it to? Each member of my family. Okay, so cool. So I need to figure out at 8 p.m. on Wednesday, get a list of all of the family members, and then email each one of them one by one. And what should I email them? I should email them a question of how their week was, right? So like already thinking about it this way, I've got kind of like steps in my head, and I've got a sort of a structure for my program already going without really even thinking about the way that I would write the code. So pseudocode, like I said, is an informal set of instructions that describes how a program operates in simple English. They say simple English here. I don't know. I've seen a lot of different kind of types of pseudocode, but the key for all of them is that it's very simple, very easy to understand. It's used by many programmers in the early development stages of a new program. And we're going to take a look at an example here. So we got a pseudocode program, make coffee, right? I want to write a program for Rusty, our personal life-sized robot, and the program's called Make Coffee. So I'm going to tell Rusty what to do to make coffee. And if I'm thinking about this, right, like this is something that like any of us can do in our time. We all kind of understand what you need to do to make coffee, but this is a good exercise to do because it kind of like leaves it shows where might the gaps in your thinking might be, right? Like you might write out some pseudocode that says, okay, plug in coffee maker, um, get coffee grounds, um, pour coffee grounds into coffee maker. But then when I think about that, it's like, okay, well, do I need a filter? How many coffee grounds do I need to pour? I need to open up the lid first, right? I need to open up the lid and then pour in the coffee grounds. So pseudocode's really good to start figuring out where things are on a high level and then using that to figure out what the even deeper details are. So in this case, right, like we can locate the coffee maker in the kitchen, fill the coffee pot with water using a nearby sink, pour the water from the coffee pot into the coffee maker, locate the coffee filter in the kitchen, right? Place the grounds of coffee in the coffee maker, place the coffee, right? Like this is a way of breaking down the problem. And now we've got 9 steps here that we can build off of, that we can use to instruct us when we start to write the code, and that we really can use to inform our decisions, our more detailed decisions. We've got another example here of a program. And the idea here is that we have this little robot in one of these 4 squares. Each square is going to be dirty, and we want to write a program for our robot here to clean the squares. So the way that we could do this, right, is like, okay, well, 1, check if my square is dirty. If it is dirty, just clean it, and then figure out what other squares I can move to. Maybe what other squares might be dirty. Move to one, and then clean it, and then figure out which squares I can move to, and then move there, and then clean it. Oh, okay, cool. So we've got this kind of like set of instructions or set of things to do that repeat and repeat and repeat, right? Like we start off, we clean the square, we look for other squares, we move. Then once we're there, we clean, we look, we move. So like part of thinking about things programmatically is looking for patterns. We're looking for structures that are occurring in your program. So here we clean the current square, we look at all the possible moves we can make. If one of those moves leads to a dirty area, move there. If there's more than one option, pick at random. Otherwise, if there's no dirty area to move into, that means we're done, right? We've cleaned all the squares. So we do 1, 2, 3, and then 4, and then we go back to 1. So we clean our own square, we look for other squares to go to, we find 2, we pick 1 at random, we go there, we move there, and then we go back to step 1. We clean the square, we look for other squares that are dirty. This one's dirty, we move there, and then we go back to step 1. Clean it, look for other squares, move there, clean it. Right? We've got a loop going. Now we've got a program. We've got a thing that we don't have to really worry about that's going to keep running until the job is done. So any questions about like thinking programmatically? I mean, it's a much bigger topic than what I can cover here in like 10, 15 minutes. But does anybody have any questions about that? Cool. All right. Let's get into JavaScript. The brain. It's the brain of the thing. Okay. What we're going to learn. We're going to learn the different kinds of data that JavaScript can manipulate. We're going to learn how to store this data to use for later. We're going to learn how to make decisions based on certain conditions. And then we're going to learn how to organize code and data into meaningful units that you can reuse, move around, and build your code base with. So the history of JavaScript. JavaScript was created in 1995 by a guy named Brendan Eich for a company called Netscape. And it was included in the early version of Netscape 2. It was a way kind of for, they wanted a program that would, or a language that would keep doing stuff, and that even if it errored, that it would keep on running, right? Other programming languages, if there is some kind of error in them, they will stop. They will not continue to run anymore. They're like, look, there's a problem in the works. We got to stop everything. JavaScript's meant to sort of adapt and keep on running even if something goes wrong. What is ECMAScript? Maybe you've heard of ECMAScript before. ECMAScript is the standardized scripting language that forms the basis of JavaScript under the organization ECMA International. So that's a fancy way of just saying that there's this group that says this is what JavaScript should look like and should include, and everybody's like, okay, cool, that's the standard for JavaScript. JavaScript's really popular. As you can see on this chart here, a bunch of programming languages, and JavaScript has stayed at the top for the past like 4, 5, 6 years. The reason that it's really popular is that it is becoming used more across the stack. Traditionally, JavaScript was used in browsers, what they call front end, or the client. The web page loads, it has HTML on it, and it also has JavaScript, and JavaScript is written for the browser. Then around 2008, there were some breakthroughs in where you could write JavaScript. And so there was this program called Node that came out that enabled us to start writing server-side applications. So like back-end stuff, data retrieval, filling out API requests. We can write all that in JavaScript now as well. And then we also even have databases which store JSON, JavaScript's object notation, like documents. We can store information in JavaScript notation as well. It's pretty cool. So we've got JavaScript all the way across the stack, and that is why it's become so popular. Why JavaScript? Like I just kind of said, the future of web development has moved towards sophisticated and responsive dynamic single-page applications running in the browser. Wow, that's a bunch of words. Basically, like probably like 10, 12 years ago, what you did, right, when you went to a web page is you would go to like your home page, and then it would take you to a completely separate page when you wanted to do something like go to my profile, right? It would take you to another page. That's changed considerably over the past about decade, I guess. What's happened is that as JavaScript got more sophisticated and as people started using it more and more, they figured out ways to say, hey, we're just going to have one page that you visit. You'll visit this page, and then we'll pull elements in and out and change the data that you see using JavaScript. So a great example is like Spotify, right? Spotify, you don't have to go to different pages based on what song you're playing or what album you want. Really what's happening is there are elements, there are HTML elements that show the different albums or the different artists, and you bring those to the page or hide those from the page or play a song based on clicks of a button and JavaScript. So some other apps that use this type of programming is Gmail, Asana, Trello, Facebook, Google Maps. JavaScript's also great for beginners. It's because it's used across the full stack. Like you can start to write applications and start to build things without having to learn 2 different programming languages. So it's really cool. Any questions on the history of JavaScript and why JavaScript is so awesome? Okay, cool. All right, so we're going to move right into data types, types of data. Um, data data is just like stuff. I'm I'm uh, I'm trying to think of like an easy way to write, like to talk about what data is. It's stuff. It's like numbers or words or like chunks of numbers and words. It's just it's data, right? We can store data in a number of ways, but the primary way is through these things called variables. Variables are they hold values. Values are data types that have a specific purpose and intrinsic behavior. So like here, the number 50 has a specific purpose and intrinsic behavior. Number 50 is different than the word George, right? We kind of like intuitively know that those two things are different and have different purposes. They're both values, and they're both different data types, right? One is a string, a word, and the other is a number. Um, a variable is an identifier or like a label for that value. It's something that you can attach the value, attach a value to that will give it it will store that value. So later in my program, when I want to look up what is the value of num of states, because I've set num of states here equal to 50, num of states will yield, it will show a value of 50. Same thing with name. Name will, if I look up what name is and I say, okay, what's the value of name? It will be George. And finally, we have answer at the bottom. A variable cannot contain spaces. It has to be all one word. It must begin with a letter, an underscore, or a dollar sign. And it can only contain numbers, underscores, letters, or dollar signs. It's case sensitive, so like capital N num of states is a different variable than lowercase n num of states. And it cannot be a reserved keyword. So like, for instance, return is a reserved keyword. Return is a word that JavaScript will see and expect it to do something. So you can't have a variable named return. And variables can be either created with the let or var keywords. The scope of this class doesn't cover the difference between the two, so feel free to use either one. Okay, data types. We have primitive types, which is just like simple stuff. So strings, numbers, Booleans, which is a value that's either true or false. You have this thing called undefined, which basically means that the variable was never given a value. And then you have this thing called null, which means the variable has been given specifically an empty value, right? Like it's not, if I was to write like a zero, like a zero is still a thing, right? Zero is still a number. If we want to write, if we want a variable that is like specifically empty, is specifically nothing, that's where we use null. So those are the primary or the primitive, and then we have complex. These are like structures. These combine primitive data types, or they do things to primitive data types. We have an object, which is a key value pair. It's a data structure. It can hold many different pieces of primitive values. We have arrays, which is an ordered list of values. We have this date object, which you can use to create a date time. We have regex, which is a way of, how do I define regex? Is a way of like matching characters in a string or in a word. It's like an expression. Then we have functions, and functions do things. Functions perform actions. So there we go. We got primitive and complex. So primitive values, numbers, they're used to perform arithmetic operations, right? Common arithmetic operators, addition, subtraction, multiplication, division, right? Numbers are used to complete these operations. Strings, a series of characters enclosed by an apostrophe or a quotation mark. So they're like words, but they can be more than that. They can include symbols and spaces. They're really just a series of characters, which include letters, symbols, really anything, and then they're in between a question mark, or I'm sorry, a quotation mark or an apostrophe. So we have here a string full stack, right? It's a bunch of letters in between two quotation marks, and it's stored in the variable full stack. Then we have academy, which has a value of space, right? There's a white space, and then academy. So both of those are strings. Some things you can do with strings, you can concatenate them, which means it takes two strings and smashes them together to form one bigger string. So in this case, we say full stack plus academy, and it takes full stack and it appends that space academy to the end of it. You can also run this dot length on any string, and it will return the number of characters in that string, including 0 for an empty string. So here we have the we take the variable full stack and we say full stack dot length, and there's 9 characters in that string, and so this will return 9. Booleans, binary data types with 2 possible values, so it can be either true or false. Yep. Yeah, a Boolean is either true or it is false. It's one or the other. Null and undefined. Undefined has not been given a value yet, and null specifically has no value. These two are, we won't get into too much of that now, but just be careful not to confuse the two of these. They are different. Then the complex types, we have arrays. An array is a value that stores multiple values. It's an ordered list of values. You write it with opening brackets, commas, and then closing brackets. So here we have a list specifically that's true, the string true, false, and then 22. Arrays are similar to a list of values. Each value stored in an array is separated by a comma. And then just a little extra here, you can access these by index. So if you're in the Googling mood, you can Google access elements in an array by index. Then we have objects. Objects use a combination of properties and values known as key value pairs to store data. An object is similar to like a dictionary entry where the property represents the word and the value represents its definition. So it's much like opening up a dictionary and you're like, okay, I want the value, which is the definition, for aardvark. And I know that there's going to be only one entry for aardvark. There's only going to be one aardvark in this book. So the word in a dictionary is the key. It's unique, and it will, by looking it up, it will give me the value that is associated with it. You can think of objects like a group of keys, and then once you have the key, you'll be able to access its associated value. Functions. A function is a reusable chunk of code. You can use it again and again. A function is similar to a recipe. It's a list of instructions. It's a list of statements that are going to be performed. So here we have an example that's bake cookies, which is a function. You can choose a flavor in it by adding a value to that flavoring variable. Then so you could pass in peanut butter, you could pass in chocolate, you could pass in caramel. Then you can make the batter by combining the flavoring and a specific number of servings. Then you preheat the oven, add cookies to the sheet. So one by one, each of these things is going to be fired off. Each of these things is going to be executed whenever I tell the function, hey function, all the stuff that I told you to do inside of yourself, go ahead and do them. And that's called invocation, or calling a function, is to point to it and say, okay, now go, do all the stuff. Oop, dang it. There's always one more part of this recipe that I forget, and then I go ahead to the next slide. I just wanted to show the actual invocation here, right? So later on in our code, after we've defined this function, we could later on invoke it. And the way that you invoke it is you put these two parentheses together, and that will tell it, okay, at this line, right now, go ahead and execute the function. Go ahead and call the function. And then finally, we have comments. Comments in JavaScript can be written two ways. One is with a // and that's a single line comment. It will comment out everything for the rest of the line. And then we have multi-line comments, which is /*, and then close it off with a */, just like CSS. So there we go. That's a sort of rundown of JavaScript. Does anybody have any questions about any of the data types or JavaScript in general? Okay.